We are going to continue what we had last time about distance formula, area of a polygon, and midpoint of a line segment. So let us have the following problems. Number 1, find the value or values of x so that the length of the segment joining the point whose coordinates x3 and q whose coordinates -1, 4 is square root of 10. So to solve this, first we are going to illustrate the problem. This type of problem can be illustrated arbitrarily, meaning without the actual plotting in the Cartesian plane. Okay, so let us have just this segment, no, representing P and Q. Okay, so this is just an arbitrary illustration. Point P, and this is point Q. Coordinates -1, 4 for Q, and for P, x3. So we do not know x, no, here, meaning the abscissa of the point P. We're looking for the value or values of x. From here, the distance or the length of PQ is what? Is square root of 10, no? So using distance formula, we have distance between P and Q, or the length of that segment, is equal to square root of x sub q minus x sub p quantity squared plus y sub q minus y sub p quantity squared. Substituting the values, we have x sub p is x, no, and then x sub q -1. So -1 minus x quantity squared plus y sub q, we have 4, then minus what, guys?
3.
Minus 3, then quantity squared. And we know that PQ is equal to square root of 10. Now let's simplify this equation by squaring its side to get 10 equals -1 minus x quantity squared plus 1, no? So we have -1 minus x quantity squared is equal to 10 minus 1, that is 9. Taking the square root of its side, we have square root of -1 minus x quantity squared is equal to square root of 9. So getting -1 minus x is equal to plus or minus, but what is the square root of 9, guys?
3.
3. So that x is equal to, what is x? So x is equal to -1 minus 3, that is -4, or x is equal to -1 plus 3. So -1 plus 3 is equal to 2. Am I correct, guys?
Yes, sir.
So these are the possible values of x, okay? Therefore, we say that the values of x are -4 and +2, or x is equal to -4 or +2. Okay, guys?
Yes.
Let us have the second one. The distance between A, whose coordinates x2, and B, whose coordinates -3y, is square root of 65. Find the values of x and y if their sum is 10. So again, we can illustrate this problem arbitrarily, no? Okay, guys? Let's say this is my segment AB. This is my point A, and this is my point B, and this is the distance between them. Right? Yan. So A has coordinates x2, abscissa is unknown. B has coordinates -3y, its ordinate is unknown. We are looking for what? For the x or the abscissa of A and the ordinate of B, no? Applying distance formula, we have AB is equal to what? Guys, square root of, let's substitute directly. We have -3 minus x, quantity squared, plus y minus 2, quantity squared, okay? But what is AB? Guys, square root of 65, right? Is equal to square root of -3 minus x quantity squared plus y minus 2 quantity squared. Let's square each side to get 65 equals. So on the right side, we have -3 minus x quantity squared plus y minus 2 quantity squared. Okay? This gives us the first equation. What about the second equation? So for the second equation relating x and y, we say that x plus y is equal to what? Equals 10, no? So this is the second equation. If we're going to solve for either x or y of this, we can substitute it to what? To the variable in equation number 1, to either x or y, depending on what we are going to solve here. From equation number 2, y is equal to 10 minus x, right? From equation number 1, we have 65 is equal to -3 minus x quantity squared plus what is y? 10 minus x, no? And then minus 2 quantity squared, and that is what? This is now an equation in that will lead to what? So let's see after expansion. No? So expanding the binomials on the right side, we have 9 plus 6x plus x squared. The second binomial, when you square it, we have, by the way, this is equal to this binomial, 8 minus what? 8 minus x, then raised to 2, no? Guys? So that is 64 minus 16x plus x squared. Am I right? Guys? Yes. So combining these two quadratics, we have 2x squared. And then 9 plus 64, then minus 65, that is what? Guys, the constant. Is it 8? Guys, positive 8, no? And then 6x minus 16x is negative 10x. Okay? And that is equal to 0. Divide by what? By 2 each side to simplify further to get x squared minus 5x plus 4 equal to 0. I think this left side is factorable. So x minus 4, x minus 1. Am I right, guys?
Yes, sir.
Getting x minus 4 equal to 0 or x minus 1 is equal to 0. Remember, one of the methods in solving a quadratic equation by factoring, no? Applying what property? AB is equal to 0 if what? If A is equal to 0 or B equal to 0, no? That property. So solving for this linear equation, we have x equals 4. So x minus 1 equal to 0. That is x equals 1. Okay? These are the values of what? Of x. Okay, guys? X equals 4 or x equals 1. Okay? Now, what about the corresponding y? No? So, if you have x equals 4, what is y, guys?
6, sir.
6, no? Because the sum is 10. What about if x is 1?
9, sir.
So it is 9. There are two sets of values for x and y, no? So this is the first set. We can't write this in a point form, no, because they are separate coordinates of 2 points. Okay? So these are the possible combinations, no, of answers for x and y. Any question with that, guys? Let's have the next one. A circle has its center at -3, -2, and radius is square root of 76. Find the length of its chord bisected at 4, -1. So we have a circle. So let's draw a circle. This is again an arbitrary illustration only, huh, guys? So there are problems not really sensitive. You can illustrate arbitrarily. You can still solve the problem, no? You can analyze. But there are problems that you need to what? To illustrate in a Cartesian plane so that you will able to analyze the problem. But in this case, we can have it illustrated arbitrarily. So let's say I have a circle. I'm not going to draw anymore the Cartesian plane. Okay, guys? Yeah. So this is our circle. Okay. So center is here. Considered what? Considered C. That is our C. And then let us have a chord. So let's say the chord is somewhere here. So this is just an illustration, huh, guys. And it is bisected at this point here. Now, according to your geometry, now, if you have a chord bisected here, so meaning this is what? This segment is equal to this segment, no? Okay? And if I'm going to connect that to this center, that point of bisection of the chord or that midpoint of the chord, it is perpendicular to the segment drawn from the center to the midpoint of the chord. Get it, guys? Any point on the circumference going to center is a radius. So this is radius. Actually, this is also radius, okay? Radius, this is also radius. Am I correct? And that is given by square root of what? 76. Okay, children? So that we will able to come up with a triangle. Is that clear, children? I'm going to make it larger. I'm going to magnify the triangle. So what triangle is this, children? What triangle is this?
Right triangle, sir.
Right triangle. So you're having your pre-cal too, no? You're dealing with this. So this is our, let's say, point A, and let's say this is point M. So this is my M, and this is my A, and this is my C, no? So we know that this is square root of 76, and this is what we are looking for. Actually, we have to double. Let's call it A, small a, okay? Now, let's solve for small b. So we're looking for twice of a. So that is length of what? Of chord. So 2a. This is what we are looking for. Length of chord. Now, to get the length of the chord, we have to solve first for the b, no? Because we know m and c, we can compute that b, no? By distance formula. Okay? C going to m. So 4 minus -3 quantity squared plus -1 minus -2 quantity squared. So getting square root of, what's the value, guys? We have 49 plus 1, right? So that is my b, which is equal to square root of 50, or that is what, guys? 5 square root of 2, no? Am I correct?
Yes po, sir.
So we can now find a, no? A is equal to, by Pythagorean theorem, we have square root of, what is a? Square root of the square of the hypotenuse minus the square of b. But what is b? 5 square root of 2 quantity squared. So getting square root of 76 plus -50, no? Yeah. So, but what is square root of 76 minus 50? That is square root of 26. Hence, the chord is what? The chord is of length
2 square root of 26.
2 square root of 26 units, or simply 2 square root of 26. Get it, guys? Do you have any question with this? So let's have another one. Find the point or points equidistant from A and B, and at a distance 7 square root of 2 from -3, 2. What do we mean by equidistant, guys? Equidistant, same
Distance, sir.
same distance. So there is an unknown point, no? So we have an unknown point. Let us have a representation first. Let the point P, X, Y be the unknown point. Unknown point, no? So there are two variables involved, X and Y. So it means later we have to form two equations, no? For us to be able to solve X and Y. So let us illustrate the problem arbitrarily. We have point A and point B. Then there is a point. So let's say this is the point. Let's call it P, the unknown point. So this is the unknown point. That is XY. This is point B. We have 2, -2. And then this is point A, 1, -3. Okay? How far is A from P or P from A? That is equal to what? To its distance from B, no? That P. Am I correct, children? So this is supposed to be equal to where? To this distance, right? Next, another condition is that the distance of P from -3 to is 7 square root of 2. Let's say it's somewhere here, that point C. Okay, guys? And then how far is it from P, guys? How far is it from P? Guys,
7 square root of 2, sir.
7 square root of 2, no? So negative 3, 2 is that point C. This is 7 square root of 2. So from this illustration, we can now form relationships among the segments, no? Or among the distances involved. We're looking for what, guys? We're looking for the point P, no? XY. So let's see how many possible points we can get. We have solution. First, we have to apply the first condition. What is the first condition, guys? P going to what? Going to A is equal to what, guys?
PB, sir.
P going to B, no? Okay? So P going to A is equal to P going to B. Is that clear? So that's the first condition. Getting the distance between P and A. So we have P going to A, 1 minus X, or X minus 1 if you want. 1 minus X quantity squared, negative 3 minus Y quantity squared. So that is the left side. What about the right side? Guys, P going to B. So that is 2 minus X quantity squared plus negative 2 minus Y quantity squared. Let's square each side to get rid of the radicals. We have 1 minus X quantity squared plus negative 3 minus Y quantity squared equals 2 minus X quantity squared plus negative 2 minus Y quantity squared. Then we expand the binomials involved on its side. So squaring this first binomial here, 1 minus, so twice the product, 2x plus the square of the second. See, in a similar way, we have 9 minus or plus now, no? 6y plus y squared. What about the right side? Square the first plus twice the product of the first and the second plus the square of the second. Last here, we have 4 plus 4y plus y squared. Am I right, guys?
Yes, sir.
I can eliminate these quadratics, no? Am I correct?
Yes, sir.
And then combine those that are similar terms. So to get rid of negative 4x here, I have to add on its side positive 4x, getting 2x. And then to get rid of 4y on the right side, I have to get to what? To add negative 4y on its side, getting positive 2y, no? 6y minus 4y. So that is 2y on the right side. 4y minus 4y 0. So getting this, no? And then what about the constant? 4 plus 4, that is 8. On the left side, 10. So 8 minus 10 giving what? Negative
Negative
2.
2.
So divide by positive 2, we get x plus y is equal to negative 1. This will serve as our equation number 1. Okay, in simplified form. We need one more. So another condition is that the distance between what? What is the second condition, guys? The distance of P and between P and C is square root 7 square root of 2, no? So PC is equal to 7 square root of 2. Okay? So square root of what is the distance between P and C? That is negative 3 minus x quantity squared plus positive 2 minus y quantity squared equals 7 square root of 2. Squaring its side. So we have negative 3 minus x quantity squared. So no more radical, no? 2 minus y quantity squared is equal to 49 times 2, that is 98. Get it, guys? So let us expand the left side, binomials. So for the first binomial, 9 plus 6x plus x squared, then plus 4 minus 4y plus y squared, no? And that is equal to 98. Okay? So getting x squared plus y squared, arranging the terms, and then eliminating 98 from what? From the right side by adding negative 98 on each side. So getting x squared plus y squared plus 6x minus 4y, then 13 minus 98. What is that, guys? Negative 85. No? So that is equal to 0. Okay? So let's now consider this equation number 2. From equation number 1, we have y is equal to negative x minus 1, no? From equation number 2, we can substitute this y here. So getting x squared plus y. But what is y? Negative x minus 1, quantity squared plus 6x minus 4 times y. That is negative x minus 1 equal minus 85 equals 0. Simplifying this further, so we have x squared minus, let me write it here first, x squared plus what? Plus x squared plus 2x plus 1, no? For the first 2 terms here, after expanding this binomial here. So I'm going to move it on the other slide. Then what about the second one? We have 6x plus 4x plus 4 minus 85. Am I right, guys? So simplifying by collecting similar terms, we have 2x squared plus 12x. Then minus 85 equals 0. So divide by 2 to get x squared plus 6x minus 40 equals this is 80, no? The constant. So divide by 2 minus 40 equals 0. Okay, now? Okay, guys? So what is the factored form of the left side? X plus 10, x minus 4 equals 0. Equate its factor to 0. For the first linear equation, we have x equals negative 10. Then for the second one, we have x equals 4. If x is negative 10, what is y? The sum is supposed to be negative 1, right? So positive 9. What about here? Negative 5. Am I correct, guys?
Yes, sir.
The sum is supposed to be negative 1, no? Okay? So corresponding here, we have our first possible point, negative 10, 9. And then another possible point, we have 4, negative 5. Okay? So there are 2 possible answers. So that meaning there are 2 possible points that will satisfy the given conditions. Okay, children? Do you have any question? So let us have this number 5. show that the points A, B, and C are vertices of an isosceles triangle. So A is -1, 1, B is 3, -2, C is 6, +2. Okay? Now, first, let us illustrate the problem. So we're given this, no? This time, let's illustrate it in a Cartesian plane so that we can estimate the possible equal sides, no? Because to be isosceles, at least there are 2 equal sides. Am I right, guys?
Yes, sir.
So we have illustration here. So y, then x. X-axis. Okay. 1, 2, 3, 4, 5, 6, 7. 7, 3. 1, 2, 3, 4. So this is 4, this is 2. -1, -2, -3. -3, -1, -2, -3, -3. So plotting the points, we have -1, 1, -1, 1. Okay? What about B? 3, -2. Then we have 6, +2. Am I correct, guys?
Yes, sir.
Okay. So let's label them. So this is point A, point B, and then point C. Let's connect to form a triangle. What do you think are the equal sides, possible equal sides? From the illustration, what do you think?
A, B, and B, C, sir.
A, B, and B, C? Okay, so let's see. Now, in case not, you can change the statement that you're going to prove. What will be the basis, guys? What will be our basis in proving this, guys? What will be the basis? Meaning, what we are going to prove something. What will be your basis in proving that statement? What are we going to use? Definition of what? Of isosceles.
Isosceles triangles.
This will be our basis in proving definition of an isosceles triangle. What's the definition, guys? Guys?
An isosceles triangle is a kind of triangle that has only 2 equal sides.
I think there is a mistake in the statement that you mentioned. There is a word that you have to omit. Do you know that equilateral triangle is also an isosceles triangle? All equilateral triangles are isosceles, but not all isosceles triangles are equilateral. Okay, Iha? Or
Yes.
reward your definition. An isosceles triangle is a triangle with 2 equal sides. And that means possible to have exactly 2, possible to have 3, as long as there are 2 equal sides. Or much better, at least 2 equal sides. Clear, children?
Yes po, sir.
Okay, so we have to show that AB is equal to BC, no? In case these are not the ones equal, so you can change the statement that you're going to prove and then compute for the third one. Okay? In case it fails, no? Try to check the third one. But for the meantime, we have to compute just the two sides. So proof. To prove this analytically, you have to compute this what? This length of segments, no? AB. What is AB, guys? Square root of 3 minus negative 1, quantity squared. Negative 2 minus 1, quantity squared. And that is equal to square root of 16 plus 9, giving what? 5, no? What about BC? What is the distance? Or what's the length of BC? We have 6 minus 3, quantity squared, plus 2 minus negative 2, quantity squared, getting square root of 9 plus 16. So same, no? 5 also. So no need to compute for the third. Guarantees that there are two equal sides already. Therefore, this is what? An isosceles triangle. Meaning the given points are vertices of a right triangle. Okay, guys? Since AB is equal to BC, the triangle is what? Is isosceles. Or the given points are vertices of an isosceles triangle. Clear, children? Okay?
Yes, sir.
So we're done. Next, what about this number 6? Show that the points A, whose coordinates 2, negative 3, B, negative 2, negative 6, C, negative 2, negative 1, and D, 2, negative 2, are vertices of a rhombus. Does anyone recall a rhombus? Guys?
A quadrilateral with equal sides po.
A quadrilateral with 4 equal sides. What about a square, Iho? How do you define a square? Iho, how do you define a square?
An equiangular rhombus, or yeah.
So it is an equiangular rhombus. Meaning all the angles of the rhombus are equal. That's what you mean?
Yes, sir.
Okay.
90
good.
degrees.
So if all the angles of a rhombus happen to be all equal to each other, actually each 90 degrees, it will become a square. Another way of defining a square. Iho. Using a rectangle, how do you define a square using rectangle?
Me ba, sir?
Sorry.
Me, sir.
Yeah.
Equilateral rectangle
Equilateral rectangle or a rectangle with
with
all
4 equal
sides
sides.
equal. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 2. 1, 2, 3, 4. How many? 4. I think enough. Then we have negative 1, negative 2, negative 3, 1, 2. Okay? Let's now plot the points. 2, -3. 2, -3. You're here. -2, -6. So you're here. -2, -1. You're here. 2, +2. You're here. Okay. So let's connect them. So this is how we are going to connect to form a quadrilateral, no? And then later we're going to show that this is supposed to be a rhombus. So point A, 2, -3. What is our point B? -2, -6. This is our point B. And then this is what? 2, 2. See, that is point D. And then this is our 2, -2, -1. Point C, no? So definition of a rhombus. So what is to prove, guys? What's to prove,
Sir, AB
guys?
is equal to BC is equal to CD is equal to
AB is supposed to be equal to CD, no?
Yes, sir.
And BC is equal to AD, right? BC and AD, I think they are vertical distances, no? Or they are vertical segments. Or proof. Or let's now have our proof, meaning we compute the following. AB by distance formula is square root of -2 minus 2 quantity squared plus -6 minus -3 quantity squared, and that is equal to square root of 16 plus 9, that is 5, right? What about AD? I mean CD. This is not supposed to be n, no? Equals, what to prove? All of them are equal, no? Let me revise this. What we are going to prove is that AB is equal to CD equals what? AB, CD, BC, and equal to what else? AD, no? Okay? Am I right? Okay. So what is CD? What is CD? 2 minus -2 quantity squared plus 2 minus -1 quantity squared, and that is equal to square root of 16 plus 9, 5 also. BC. BC is a vertical segment. So you can just get the difference of the y coordinates, no? Take the absolute value, okay? -1 minus -6, then that is +5. The last one, guys, what about AD? Or what about AD? Absolute value of 2 minus -3. So that is also 5, right? Now, since all the sides are equal, of this quadrilateral, what quadrilateral? A, D, C, B are equal, it is what? It is really a rhombus, no? Am I right, guys? Yan. Okay? So we're done. What if you are asked of the area? What is the area of this quadrilateral, which is a rhombus, no? A, D, C, B. Okay? How do the points, how are the points arranged, guys? How are the points arranged? Guys, area sub 4. Counterclockwise, right? Oh, in counterclockwise, if we are going to begin with what? With A. So A, what is the next point? D, followed by C, then B. What's the ending? A again, no? So we have 2, -3, 2, 2, -2, 1, -1 I mean, -2, -6, then going back to 2, -3. Am I right, guys? So 1/2 of 4 diagonal products, -2, +12, +6, minus going up. Sum of those going up products, -6, -4, +2. What else, guys? -12. Am I right, guys? Would you please
Yes,
check? What's the answer to that? 1/2 of 18 plus 2. This is 20 minus -6 minus 4 minus 10. -20. Finally, we have +20, right? Square units, because that's area. Is it clear, children? Guys?
Yes, sir.
Yes, sir.
Okay. Next problem. A circle with center at 4, 6 has a diameter that terminates at A, whose coordinates -1y, and B, whose coordinates x and 8. Find x and y, meaning values. No? So we can illustrate this arbitrarily, no? Even not in the Cartesian plane. Let's say this is our segment. Okay, point A, point B. The center is here. Let's call this the center of that circle. So we know that B is what? X8. One of the coordinates is unknown. Point A, -1y. The ordinate is unknown. We know the coordinates of the center, no? So we're looking for x and y, right? They are not forming a point, no? Because they are what? They belong to different points. How to get the value of x and y? So x of the center is equal to what? X of A plus x of B, right? All over 2. Okay. What is x of A? -1. X of B, x, all over 2. And what about x of C? That is 4. Am I right, guys? Equals 8. What is x? Positive 9. Get it, children? What about for y? Y sub c is equal to y sub a plus y sub b all over 2. But what is y sub a? That is negative 1. Y plus 8, no? All over 2. But what is y sub c? 6. Therefore, y plus 8 is equal to 12. Or what is the value of y? Negative 4. Am I right, guys? Children? Or
Sir,
positive 4?
positive 4.
Positive 4. Y equals positive 4. Okay? Do you have any question with this? Children? So what about number 8? Number 8, guys. Anyone? Guys, show that the points A, 1, negative 1, B, negative 3, 0, C, 2, 5, and D, 6, 4 are vertices of a parallelogram. If you're going to use distance formula in proving this, you are going to use what? What basis, guys?
Sir, definition of a parallelogram.
Parallelogram is what? It's a
A
quadrilateral
with whose opposite sides are equal.
with two pairs of opposite sides equal, no?
Yes, sir.
What if I do not want to use distance formula? I want to use this time midpoint in proving this. Guys, what theorem are we going to use that will guarantee that this is a parallelogram? Guys, children, anyone? Guys, anyone, children? What theorem? Do you know any theorem that will tell us that making use of the concept of midpoint, it is a parallelogram, guys? Children, can you recall that in your geometry? Guys, children, do you know? Guys, you can't remember anymore? The opposite sides are equal length. Yeah, they are equal, but still distance. I want to make use of the concept of midpoint. Guys. So what are you going to use? What principle or what theorem? If the diagonals of a quadrilateral bisect each other, then it is what? A parallelogram. If you have a quadrilateral and the diagonals bisect each other, meaning they share a common point. If the diagonals of a quadrilateral meet at a common point, then it is a parallelogram. Okay, guys? Remember that? Or do you remember that, guys? Or not anymore? Guys, not? Guys?
No, sir.
Not anymore? Oh, that's so sad. Not remembering. Why? 1, 2, 3, 4, 5. Okay, let's plot the points. We have 6, 4. Where is 6, 4? 6, 2, 4. 6, 4. Somewhere here. 6, 4. Then 2, 5. 2, 5. B, negative 3, 0. A, 1, negative 1. Okay? So, connect. To form a quadrilateral, because we are not sure if this is really a parallelogram, no? Okay, guys? Yeah. So this is point D, point C, point B, point A. What will be the basis, guys? If there is a theorem, if the diagonals of a parallelogram, of a quadrilateral, bisect each other, when you say bisect each other, it means they have a common midpoint, no? Bisect each other. Then it is what? A parallelogram. Clear, children? So what to prove? Guys, you have to show that the midpoint of what?
The midpoint of AC equals the midpoint of BD.
Yes, no? This is to prove, no? To prove midpoint, midpoint of AC, that segment is equal to midpoint of BD, no? Okay, guys, so this is it. Let's use other color. This is the diagonal. Another diagonal. We have proof. Oh, we have to compute this, no? Also, the midpoint of BD. For midpoint, let's call it M, no? Of AC. Oh, what are the coordinates? AC. AC, 1 plus 2 all over 2. What about the y coordinate? Negative 1 plus 5 all over 2. Am I correct, guys? What is that midpoint of AC? Well, what about midpoint of BD? Let's check. BD. -3 plus 6 all over 2. 0 plus 4 all over 2. Oh. What is this, guys? What is the left side? 3 halves. Positive 2, no? What about the right side? Guys,
3 halves positive 2, sir.
are they coincident, the points? Yes, no? They coincide here. So meaning, the diagonals bisect each other because these are supposed to be equal and these are equal to, but they are not equal diagonals, huh? They just what? They just meet at a common point so that its diagonal is divided into 2 equal parts, no? But its diagonal, I mean the diagonals are not equal to each other. Okay, guys? Yan. Since the midpoints coincide of AC, is it AC? Am I right? And BD. Let me check to make it sure. BDAC. Coincide, meaning are the same. The diagonals AC and what, guys? And BD bisect each other, no? And hence, not roosters, and hence, the quadrilateral ADBC, am I right? ADCB, ano nga? ADCB is what, guys? Is a parallelogram. Am I clear with this, guys? Guys? Children?
Yes, sir.
Okay. But of course, this is not the only way, of proving. This is another way. In case there is no specific requirement in proving the given statement, you can do whatever you want as long as correct, analytically. Okay, guys? But using analytic, meaning by computation, not like in geometry, synthetic geometry. You make use of statements, then support another statement, then reason, and so on to prove a given statement. Okay? Sorry. Let us have the last one. What number are we now? Actually, when we go to parallel, concept of parallel lines, another way to prove is to show that opposite sides are parallel. Okay? To be parallelogram. Number 9. Number 9. So what about this problem? The 3 consecutive vertices. By the way, let's find the area. Letter B, find the area. Of quadrilateral ADCB. That's how the points are arranged, in counterclockwise direction. So area is sub 4. That is equal to 1/2 of. So we have A here, D here, C, B. Then going back to A. Okay, guys? So What are the coordinates of A? 1, negative 1. 1, negative 1. What about the D? 6, 4. This is 2, 5. What about the B? Negative 3, 0. Okay? Then going back to 1, negative 1. Getting now the diagonal products going down. 4. Take the sum, no? 30. 0. Minus. There's another one, I think. Plus 3. Minus negative 6 plus 8 minus 15 plus 0. Okay, guys? What's the value? Anyone can help? Anyone, please help me computing the value, guys. This is 1/2 of what? 37 minus negative 13. What is that, guys? Is it 25, the area, guys?
Yes, sir.
Sir, 25.
25 square units. That's it. Actually, there is another way of finding the area, making use of matrices. If you use matrices, guys, determinants, making use of determinants. So you have to divide into what? Into triangles. You will able to get the area by what? By using determinants. Okay? This is number 9. 3 consecutive, yan, 3 consecutive. When you say consecutive, what does it mean? You're not supposed to what? To change arrangement, no? 3 consecutive vertices of a parallelogram are 4, positive 2, 2, 6, 2, 6, and 6, 8. And 6, 8. Find the 4th vertex. Find the 4th vertex. Get it, guys? So let's illustrate. 3 consecutive vertices of a parallelogram are 4, 2, 2, 6, 6, 8. They are all in the first quadrant. No? Am I right? First quadrant. Maximum y is 8 from here. Then we have for the x 6. So let's say this is 6. This is 3. We divide into 3. And then okay. So this is 3, 6. 1, 2, 3, 4, 5, 6. Then we have 4. 4 here. Let's say this is 4. Divide into, then another 4 here. Okay, guys? This is 8, 6, 4, 2. Okay. Plotting the given points. 4, 2, 4, 2. 2, 6, 2, 6 here. 6, 8, 6, 8. Okay, children? If I'm going to begin with A, because consecutive A, it is connected where, guys? Where is my A? 4, 2? This is my A, right? Let's label that A. This is supposed to be C. And this is supposed to be B. Am I correct? If I'm going to begin with A, what is my next point, guys? Guys,
B, sir.
B, because consecutive, I'm going to connect it. Not to C, no? But to B. Because if you connect it with C, or to C, so you will form another parallelogram. Not what we want. A going to B, then B going to C, right? So I have no choice but to go to where? To somewhere here, no? Am I right? So I will draw parallel to the AB, and then I'll try to stop if that is all equal to that. So approximately, let me say it's equal to this. And then going here. Am I right, guys? So this is what we want, no? What we really, really want. And let's call it point D. And we do not know that. Let's call it XY, the coordinates. Okay, that D, coordinates for the D. Get it, guys? So B, 2, 6, C, 6, 8. Did you get that, guys? Or how are we going to compute for the D? We can make use of what, children? Concept of midpoint, no? Yan. If I connect what? Because this is parallelogram, I want to form parallelogram, the midpoint of this diagonal must be equal to the midpoint of this diagonal. Is that right, guys? Guys?
Yes, sir.
Yes, sir.
Yan. We're looking for this midpoint. Yan. So we have to get for that midpoint first. Midpoint of what? Midpoint ni AC must be equal to what? Midpoint of BD, no? But what is midpoint of AC? Guys, we are looking for almost time. X and Y, no? What is midpoint of AC? Because we can compute that, no? Guys? Midpoint of AC is, guys, what's the midpoint of AC?
5, 5, sir.
Okay, so that is AC, no? 4 plus 6 all over 2, no? Then 8 plus what? 8 plus
2.
2, no? Arrangement does not matter. 4, 8, and 2 together with 4 plus 6. No? You can have 2 plus 8 or 8 plus 2. And this is supposed to be equal to, guys, to what?
5, 5, sir.
2, then no, 2
2 plus
X,
X,
no?
sir.
All over 2. And then we have 6. I just make it this way, no? But actually you can compute separately the equation. 6 plus Y all over 2. Getting what? Getting 2 plus X all over 2 is equal to, what value?
5, sir.
5. What is X? 10
8.
minus 2. 8. Is that right?
Yes, sir.
So that's the value of X. Actually, what we want, not really XY, but we want the D, no? Point D, XY, the point. So what about the other one? 6 plus Y all over 2 is equal to
5, sir.
5, 2, no? So Y is equal to 4. Am I right?
Yes po.
So what is the point D? So therefore, the fourth vertex is what, guys? Of the parallelogram is what? Guys,
8, 4.
yan. Is D 8 then 4. Okay? Any question with that, children?